Okay, we'll go ahead and get started here. We have this last little part of Chapter 7 where we are talking about sample proportions now. So before we were talking about sampling distributions, now we're going to talk about proportions. So you're going to see these as percentages. So in the previous section, we were concerned with the sampling distribution of a sample mean, which is x bar. Now we're going to be concerned with the sampling distribution of a sampling proportion, which we're now going to have a new notation, which is going to be P. Let me get a little more room here. It's P with a chevron over it, or layer up caret here, but we call that P hat. Okay, now a proportion is a percent. So you're going to see percentages in decimal forms. So proportions now, you see a percent in a problem, it's a proportion. The percent of observations that possess a given characteristic, so percent male, percent in favor, etc. Or you could say 4 out of 10. So it could say that, and then you will then be prompted, or you will need to find the proportion, which would be 4/10 or 0.4. So sometimes it'll give you the decimal form, sometimes it'll give it to you in raw form, and then you will convert to a decimal. The sample proportion is the percent of the sample that possess the given characteristic, so 4 out of 10 students received an A in the class. Then the population proportion is the percent of the population, so the total population that possess that given characteristic. Okay, now we have your formulas here for this. So you have, for a population and a sample, this is your mean of your population or sample, your p hat, okay, or your p. So just p, this is going to be for population, so this is x over n. So x, the number of elements in the population with the characteristic of interest, and n, the population size. Okay, so that gives you, this is for population. And then p hat, it's x over n again, okay, for a sample. It's just little x and little n. So little x is the number of elements in the sample with that characteristic, and then n is the sample size. And then q is going to be the number that do not possess that characteristic. So 1 minus p. Now, in order to proceed when we are doing proportion calculations, we need to follow the central limit theorem. So it's just a quick check, and most of the time it'll say that this works in the problem. But here you have the central limit theorem for this is going to be that if both NP is greater than 5 and NQ is greater than 5. So the sample size times P and Q needs to be greater than 5. Then the sampling distribution of the sample proportions, then we can assume that it's going to be normal. So again, normal distribution with a mean of, and we'll call this mean, so mu of p hat, little p hat here. And a standard deviation, sigma p hat. For your notations there. So you have mean of p hat, that's mean of the sample proportion. And then sigma p hat, standard deviation. Okay, of sample proportion. Okay, now that will be, we'll assume it's normal regardless of the shape of the distribution. It may be greatly skewed or not bell-shaped, but as long as NP and NQ are greater than 5, we are going to force it to the normal curve. Okay, then we have the notation for mean, which we have up here, is mu little p hat. We're going to say that's always just going to be equal to the population mean. So therefore we write that mean of p hat is equal to p. So mean of the sample proportion is going to be equal to p, the population mean. Just like it was for the last section. Okay, so as long as we have the central limit theorem in effect, the mean is going to be the same across the proportion and the sample proportion and the population. And then the standard deviation, the notation sigma p hat, and that is going to be equal, so formula here, it is pq divided by n, and it is the square root of that. Okay, and then that is the standard error. So we refer to that as a standard error. Okay, so formula for standard deviation of a sample proportion, square root of pq over n. Okay, and then before we change the page, one more thing, z-scores for this. So you're going to use p hat minus p over the standard deviation of p hat. So the value p hat that we're trying to find, so basically your x there, minus the population mean over the standard deviation. So really the standard deviation calculation is different depending on if you have a population, a sampling distribution, or now a sample proportion. Yes, these will be on the formula sheet. All right, so let's look at an example. So we have, according to a Gallup poll in 2018, 62% of Americans identify as middle or upper middle class. Let p hat be the proportion of a random sample of Americans who identify as middle or upper middle class. Okay, so what we know here is we know that p hat, or p, the percent of Americans, so that's your mean, is 62%, so 0.62. Which means that q is 1 minus 0.62, the percent of Americans that do not identify as middle or upper middle class, which would be 0.38. Okay, so let's identify the mean and the standard deviation, okay, for a population or a sample size of 36. Okay, so the mean is always just equal to p. So here we say 0.62. And then here, let's just do this before we do the standard deviation, because the reason why we can say the mean is equal is because we're going to assume NP and NQ are greater than 5. Which we can actually do a quick check with that. Okay, you have 0.62 times 36, and then 0.38 times 36. So those are both greater than 5. Okay, so 36 is the n, and then you're multiplying by p and q. Okay, you can do that quick check. The problems I give you, they're all going to be fine. You're going to be able to proceed, but that would be if you're writing a paper about statistics, you want to put those checks in. You want to look for those things. Okay, now the standard deviation is, remember this calculation here, the square root of p times q over n. Okay, so we would have here p times q, so 0.62 times 0.38 divided by 36, the square root of all of that. Okay, and we should be able to put this in our calculator as long as we do it carefully. Let me pull up the 84 here. Okay. All right, so I'm going to go square root, and we're going to go parentheses for the numerator, 0.62 times 0.38. Close that numerator, then divide by 36. So that should give you 0.0809. Okay, for that standard deviation. And I just like to check one step at a time because I just want to make sure the calculator has it correct. So 0.62 times 0.38 divided by 36, and then the square root of that. Okay, get the same thing. So you can put it in as long as you put the parentheses around the numerator there. Okay, now with a larger sample size, okay, that's going to change the standard deviation. The mean will remain the same at 0.62. Now with this sample size, if we had a smaller sample size and it was NP and NQ greater than 5, we were fine. Then we know with the larger sample size, it will also be fine. Here we'll have same calculation, we just have a different denominator here, so 0.62 times 0.38, now over 75. Okay, so the standard deviation of the proportion will change based on the sample size. So you have square root, parentheses, 0.62 times 0.38, close parentheses, divided by 75. There we're going to get 0.0560. Okay, now let's do a probability problem with that. So we have if in that sample of 75 Americans, if they're randomly drawn, determine the probability that less than 76% of the sample identifies as upper or middle class. Okay, so here you want to say what is the probability that p hat is less than 0.76. Okay, so this is kind of like your x. P hat and x will be similar there. So what's the probability that that's less than 76%? We've got a sample size of 75. We had p of 0.62. We had q of 0.38. And that standard deviation of p hat, we already found it in the previous example. So it's for the 75, so 0.0560. Okay, then we will do the same thing we've been doing for all of Chapter 6 and the beginning of Chapter 7. We'll find the z-score, and then we will plot it, and then we will do normal CDF. The difference is, what standard deviation calculation am I using? So you have to, when you're looking at these problems, identify whether you have a population, a sampling distribution, or a sample proportion. Okay, and we'll go through when we review kind of what things we're looking for there. Okay, so for here we'll do the z-score. So you're going to have your p hat, which is 0.76, minus p, 0.62, over our standard deviation, 0.0560. So that's going to give us, let's see here, 0.76 minus 0.62 divide 0.0560, 2.5. Okay, so we have a z-score of 2.5 right here. You want the probability that p hat is less than that. So this is all to the left. So this should be pretty high percentage here because it's most of this curve. Okay, here I would go normal CDF. And then we have, going to the left, negative 99, upper limit 2.5. So second distribution, normal CDF, negative 99, upper 2.5, paste. So 0.9938. Okay, so in a sample of 75 Americans, there is a 99.38% chance that less than 76% of them identify as upper middle class. Or middle or upper middle class. Okay, now let's look at example 2.2. We'll do another one. So according to recent research by the Communications for Elidman, 56% of people worldwide believe that capitalism as it exists today does more harm than good in the world. Let p hat be the proportion of people in a random sample who believe this. Suppose a random sample of 100 people is selected. What is the probability that more than 59% of the sample believes that capitalism as it exists today does more harm than good? Okay, so what we are given, sample size is how big? 100. All right, P is what? The population percentage? 0.56, which means Q is 0.44. Now, if I did a quick check here, NP would be 56, 100 times 0.56, and NQ would be 44 with that. So we're good with that. Sample size is big enough. All right, standard deviation of this is going to be 0.56 times 0.44 over 100 and the square root of that. So let's go ahead and find that. So square root, parentheses, 0.56 times 0.44, close parentheses, divide by 100, 0.0496. Okay, so we have all of that, and then we want to write down what we're looking for. So we're looking for the probability that p hat is greater than 59%, so 0.59. So we will find the z-score for that. We will go 0.59 for my p hat minus p 0.56 over my standard deviation 0.0496. Okay, so 0.59 minus 0.56 divided by 0.0496. We have 0.6048. Okay, so we have our z-score. Next, we will put it on the curve. So it's just slightly past 0.5, about right here. And we want greater than, so I'm going to highlight to the right. And then for the probability, we will go normal CDF. .6048, positive 99. So 0.6048 for our lower limit, upper limit 99. Keep the mean and standard deviation at 0 and 1, and we get 0.2727. Okay, so the probability that more than 59% of a sample of 100, so 59 people, there is a 27.27% probability that more than 59 people in this sample believe the statement. I'm just going to write the statement. I'm not going to write the whole thing out. Just as a best practice, if you were to go take the AP test and you did all of this and didn't write this all out, you wouldn't get full credit. Okay, so let's go ahead and go to the next page. We're going to increase the sample size. Okay, so sure. Okay, so suppose we take the random sample and increase it to 300, and then now we have the probability that between 140 and 185 people believe this. So now this is giving it in slightly different terms. So first you have the sample size of 300, and then P and Q are still going to be the same because that's based off the population. So based off the population, it's 0.56 and 0.44. And the standard deviation, now we will change with a different sample size. So you have 0.56 times 0.44 over 300, square root of that. So let's find this standard deviation. So square root, parentheses, 0.56 times 0.44, closed, divided by 300. We're going to get 0.0287. Okay, so we have all of that. Now we want to find the probability that between 140 and 185 people believe the statement. It's not given as a percentage. So because P and Q originally are as a percentage, we now have to convert that into a proportion, which is really just this, 140 out of 300 and 185 out of 300. So it's the probability okay, that P hat is between this, which is 140 out of 300. That's going to be 0.4667. And then 185 out of 300 is going to be 0.6167. Okay, so we'll need to find the z-scores for each of those values. So we'll start with the 0.4667. So 0.4667 minus P, which is 0.56, over our standard deviation we found to be 0.0287. Okay, so 0.4667 minus 0.56, and then divided by 0.0287. 0.287. So negative 3.2509. And then our second z-score will have 0.6167 for this upper end here, minus 0.56 divided by 0.0287. Let's see what that gives us. So 0.6167 minus 0.56 divided by 0.0287. So 1.9756. Okay, now we will take those values. We're going to go over to our normal curve here, and we want between negative 3.25, so about right here, and 1.97, so almost at 2, right here. Okay, so this is what we're looking for, all of this area in here. So that should be close to probably between 95 and 99%. But we'll go normal CDF with these values. So lower limit, upper limit. And let's see what that gives us. So second distribution, normal CDF, negative, oops, I went to inverse norm. There we go. All right, negative 3.2509, and then 1.9756. Paste. We're going to get 0.9753. Okay, so in there, the probability that between 140 and 185 people believe that capitalism as it exists today does more harm than good is 97.53%. Okay, for the next part, I want you guys to take this population of 18,000 and a p of 0.25 and find, let's see here, for a sample size of 70, a z value for each of these. Just your z values. So try that real quick. You really don't need the 18,000. I think that's there to throw you off. So find the p, q, and the standard. 1 second, I'm speaking. Find p, q, and then the standard deviation based off of the sample size of 70. And then you'll do the z values. All right, let's go ahead and take a look at these. So we have a sample size of 70. You have a p of 0.25, which makes q what? 0.75. Okay, so we will find the standard deviation of p hat. So we'll go 0.25 times 0.75 over 70, square root of all of that. So we get square root 0.25 times 0.75, close the parentheses, divided by 70, enter. So 0.0518 for that standard deviation. Okay, and then here we're just finding the z-scores. So the z is going to be p hat minus p over the standard deviation of p hat. So that standard deviation is going to be the same for all of these. This first one is going to be 0.26 minus 0.25 over 0.0518. So there we should get, let's see, 0.01 divided by 0.0518. That'll give you 0.1931. For B, 0.32 minus 0.25 over 0.0518. Let's see, 0.32 minus 0.25 divided by 0.0518, 1.3514. Okay, the next one, 0.17. So 0.17 minus 0.25 over 0.0518. So 0.17 minus 0.25 over 0.0518. That's going to give you negative 1.5444. And then the last one, 0.20 minus 0.25 over 0.0518. So there you should get negative 0.9653. All right. Any questions about that? How are we feeling towards this? Okay. This next practice is really for preparing for the test, so I wanted to leave that, but let me see if I can find anything on your homework. Okay, so here's one we can do. So we have, according to recent research, 37% of Americans have less than $300 in the bank for an emergency. Let p hat be the proportion of people who have less than $300 in the bank for an emergency in a random sample of 79 Americans. Determine the probability that the proportion of people in a random sample of 79 Americans, I hate how they keep repeating the sentences, but have less than $300 in the bank for an emergency, is within 7% of the population proportion. And then we'll do another one. Okay, so let's write what we have here. So we have a sample size of 79. Our population percentage, P, is 0.37, which will make Q, what's that going to be? 0.663? 63. Yeah, 0.63. Okay. And then we have p hat, we'll come here, p within 7%. P hat is 0.07 here. Okay, so let's go ahead and find our standard deviation. All right, so that's going to be 0.37 times 0.63 over 79, square root. Yes. This is chapter 7. This is just a homework practice problem. I just pulled it up from the homework. Okay, so that's going to give us a standard deviation of 0.0543. Okay, so we want to know the probability that let's see, Americans who have less than 300 in the bank is within 7% of the population portion. So let's find the z-score for 7%. So it's going to be, z is going to equal 0.07 minus 0.37 over 0.0543. That's going to give you negative 5.5249. Okay, actually scratch that, because that does not look right. Within 7%, so p hat is not going to actually be 7%. We want it to be within 7% of the population proportion. So it's within 7% of, what's the population proportion? This, yeah. So we want it where p is between, that would be 30% and, what's 37 plus 7? 44. 44, right? Yeah. So, so within 7%, it would be 37 plus minus 7. So 30 and 44. That's what we want. So 0.30 and 0.44. So we want p that it is between 0.30 p hat and 0.44. So when I did the other calculation, when I saw the negative 5, I was like, that can't be right. That's a really high number, because usually it's going to be between negative 3 and 3. So when you're looking at those things, that's why it's helpful to have the chart, and then you see a really high number like that or a low number, it will prompt you to reread the question, things like that. Okay, so now we'll want to find the z-score for those two percentages. So let's see, z-score for 30%, we'd do 0.30 minus 0.37 over 0.0543. And that is going to give you negative 1.2891. That looks better. And then our second z-score, we'll do 0.44 minus 0.37 over 0.0543. And that'll give us positive 1.2891. So on the chart, okay, that's going to look somewhat like this. We want this value here in between. So we would do normal CDF with those two as our upper limit and our lower limit. So second distribution, normal CDF, lower limit negative 1.2891, upper limit 1.2891. That's going to give us 0.8026. So we would put that in right here, 4 decimal places. Okay, that works. So I just checked it on the homework, because the homework key says 0.8025, so it's within 0.001. It still accepts it. So you're good to go. Um, probably not. Probably not. But I haven't made the test yet, so there's no guarantee. So I'll have to look at the test and I'll see. But I think most likely in the past I haven't done it like that. Because it does kind of throw you off a little bit. Because you're used to greater than, less than, or between. 63, the 0.63, 0.63. So if P is 0.37, then Q is 1 minus P. So 1 minus 0.37 would be 0.63. Because P and Q have to add up to 100. Mm-hmm. Mm-hmm. All right, so then the next one also is a different weird wording. So determine the probability that the proportion of people in a random sample of 79 Americans who have less than $300 in the bank for an emergency is greater than the population proportion by 5% or more. So it's a little bit easier, but it's P isn't 5. Its P hat is greater than the population proportion by 5%. So the population proportion is 37%, so this would be 42. So 37 plus 5. So greater than by 5% or more, so 0.42 is what we're looking for there. So follow the same procedure, find the z-score for 0.42. I'll do this in a different color so it's different. So 0.42 minus 0.37 over 0.0543. So that's going to be 0.9208. And then this chart, that's a weird curve, but 1 would be about right here. And you'd be going to the right for greater than. So there we would want to go normal CDF, 0.99, there we go, 9208 and 99. Oh, wrong one. All right, so .1786. So we'd put in here 0.1786. Probability that 42 or more percentage of people in that sample of 79 Americans have less than $300 in the bank for an emergency.